Hi, my name is William St. John, and for a hobby, I work I play with these physics just to see what I can see out there. All I've done is use a pen and paper and a calculator, and I start out very simple stuff, and then I start getting more advanced as I start learning on my own. Um, some I learned from books, some of it, most of it, is just what the paper logic told me where to go. So I just want to show you how I can go from one constant to another and kind of explain uh, each constant uh, where they kind of interrelate with each other. Um, Let me start with this formula here. This is from the binding energy I started with in the beginning, and this is the mass of the neutron minus the mass of the proton, and then divided by the mass of the electron. To make both sides equal, I just do that. So that's what I started out with, and I don't know what you'd call it, a geometrical carrier. It's basically lines and circles and things like that for the base, like a train track, where everything else, more complex things, rides on it. I started with a equivalent to a radian. Forgive my handwriting here, but I'll explain every little scribble I'm doing here. 2 pi times the square root of natural log now theta naught, it just means it's a degree. On both sides of the equal signs, both sides will have a degree. The system, what I figured out, you have to add it because nature doesn't apply it. But on the from the radian side here and the 4 pi side part of it, you can plug in equivalencies, and you can work at both directions. It's more like a coupling formula. And for instance, get a little more complex here. If I work in the 4 pi area, that is equivalent 2 times, and this is the golden angle, little g, times the golden ratio square divided by radian. So you can plug in 4 pi inside that coupling formula. You can do for that. You can go even further if you want. Let's get a little more complex. Let's do a elementary charge square times the speed of light times the magnetic constant. Find structure constant and Planck knot. That is equivalent. You can actually work it on the radian side, what I've just done here inside the parentheses as well. So you can actually convert from one to another. Now, let's see what we'll write on the tracks here, what I've just showed you. Let's start with a Rydberg constant. It's a constant that's used mainly in the electromagnetic spectra of an atom. They use it as spectra, studying like stars and things like, and elements and stuff like that, what's in materials. I'll show you here how related this is. We'll do this version. It's Rydberg infinity. You'll see the similarity here. This is the mass of the proton times the velocity of the electron, h, and then times fine structure constant to the third power, divided by 2, and that gives you your Rydberg formula. Now let me show you what the mass of electron, how close this is to it. It's very similar. Mass of the electron here again I'm working outside the 4 pi on the other side of the equation. Here's your mass of the proton times velocity of the electron. I use a minus here because the other side is minus. It just means it's going the other way. But fine structure constant by itself, right there. And c is the speed of light. But you can see how similar the two are. To address what we've done on a higher scale, which is a little more simplistic, mass of the proton of this 4 pi is equivalent to the mass of the neutron minus mass of the electron. But you can see the first constant. Second one I work on is G, gravitational constant. And to explain this out, this is the acceleration of the universe. Radian times, and what that means, it's the area density. Area density is equivalent to 1 kilogram per meter squared. And that's just like a, like a square here, 1 meter, 1 meter. And thickness is 0. It's just two-dimensional, and the whole 1 meter deal square is equivalent to 1 kilogram. You can take this formula, see how it's close to the coupling I showed you, and reduce this down. Gravitational constant. And you can still see it, it's kind of similar. That's the reduced version of that. That's the gravitational constant. Now the acceleration of the universe is Hubble's constant times the speed of light. But I can go a little bit further. Gravitational constant times like that. The going a little further, I guess I can explain the elementary charge. This is a little different formula. It's elementary charge. I'll make that amperage because it's negative because of the other side of the equation. This is what I figured out as well. That's Planck's constant, mass of the electron, square, and this is to borrow general relativity here. Lorentz contraction, basically, that's what this is. To make that equal. That's the electron going around the atom on the ground state, and using Lorentz contraction to figure out the absolute value of the fundamental charge. Now, another interesting thing I found for this formula here was the volume of a torus, which is a donut three-dimensionally, basically. And basically a pole runs through it, but I'll just explain the torus. You've got the inside radius, and you've got the outside radius. The small r is minor, the big R is major. Move that out of the way. And I also noticed that the volume of this torus, which is used in magnetic fields, it's not stable. Let me see. Volume, forgive my writing. And this 2 pi here would be the same here. So I assume that's related to the torus. Of the magnetic field. It's what causes that to form. Getting back to the formula, proton. Let's look at my battery's ready to die. Baryon. I can also calculate its mass. U, that's up quark, plus down quark. I'll hurry because my battery's ready to die. Neutron, it's also a baryon. Still got 3 quarks. This one's up, down, and down. These are addition signs. You add the masses of these quarks together, and it gives you the mass. To go a little bit more, still pion. It's a meson. Symbol is that. It's equivalent to two quarks, up quark and down quark. Now I can go calculate the, for instance, let's do deuterium. Give my spelling. Mass of the proton plus mass of the neutron minus the binding energy. Now the binding energy is equivalent to natural log E. Since there's a negative right there, I just put this parentheses, put a negative so it comes out as positive. Now sometimes I formulate, sometimes I think, I theorize that here, this could equal to a neutrino, electron neutrino, since it's almost massless anyway. And I can go further, but this is all I'm going to do in this video right now. This is just a demonstration of what I've come up with over the years. I can calculate between the very small to the very large, and if I make another video, I may do a little more complex series of formulas beyond this. But this is just an intro, just to show you what I've come up with, and let me know what you have in the comments, and I appreciate your time watching this. Forgive my writing, but this is the best I can do right now to get the word across. So thank you, and I'll talk to you later. Thank you. Bye-bye.